Hey guys, welcome back to Technical Math. This is our final chapter. And what really makes me excited is if you look at your Technical Math textbook, Chapter 12 actually is the final chapter. So feel pretty proud of yourself. We started at Chapter 1 and we are ending at Chapter 12. We completed an entire math textbook in one semester. So big pat on the back to you. And without further ado, let's hammer through this last chapter. Working with the abundance of information available to us today is a major problem for scientists, technicians, business personnel, and those in management positions. So the deal here is that when you are looking at something, there is so much information available. And so what we need is ways where we can organize and we can analyze all of that numerical data so we can make it meaningful and useful. And that's what statistics is. So this blank, go ahead, put in statistics. Statistics is a branch of mathematics that provides us with the tools that we need to do this. We can take numerical data and create graphs and do some calculations and all of those different things. So in this chapter, we will cover the basics, okay? So no fear here, we're just looking at basics, okay? Basics of how to read statistical graphs and how we can calculate some statistical measurements. We will use these techniques to help analyze some data. Starting off with some graphs. Graphs allow us to transform a collection of measurement numbers into a visual form that is useful, it is simplified, and it's brief. Every graph tells us a story, and you need to be able to read it. So we're starting off with what is called a bar graph. And a bar graph is primarily used to compare data. So here's an example of what you are going to see on that final test for the class. I will give you a bar graph and then you'll have some questions to answer, okay? The following graph shows the hourly energy consumption of 8 different appliances. Study the graph and answer the questions, okay? So one thing, you always want to make sure that you check the labels. So these are gas appliances. Now here it's energy consumption and it's 1,000 BTU per hour. And it's important that you realize that this is by the thousands. So when you see that this is 5, it actually means 5,000. When this is 15, it's actually 15,000. So that is one thing to always make sure that you check out those labels. Okay, so A, which appliance has or uses the most energy in an hour? Okay, so all of these bars are telling you how much BTU per hour by the thousands. So all you're doing to see which one uses the most energy, you look for the highest bar. So in this case, it is the range or oven. Which appliance uses the least amount of energy? So again, you are just looking for the lowest bar. And in this case, it is the refrigerator. How many BTU per hour does a gas barbecue use? So we have to go ahead. All of these appliances are gas. Here's the barbecue. So if I just go over, it's 50. But you need to remember that this is really thousands. So it's 50,000 BTU per hour. So again, that was where it was important to know that it was in the thousands. How many BTUs are used by a log lighter in 15 minutes? So here's a log lighter, okay? Now remember, this is per hour. So let's go ahead and figure out how much per hour first. So this is 25. Remember, it's thousands, but that's per hour. If we're looking at 15 minutes, there are 4 15-minute increments within an hour. So what you'd have to do is take 25,000 and you go ahead and you just divide it by 4 so that way you know how much is in 15 minutes. So it'd be 6,250 BTU per 15 minutes. Okay, the last question for our single bar graph. What is the difference in energy consumption between a 50-gallon water heater and a clothes dryer? So difference, okay, think way back to chapter 1. We talked about some of those key words in math. Difference is an indication for us to go ahead and subtract. So if I take 50-gallon water heater, notice that's 50. I'm comparing it with a clothes dryer. The clothes dryer is right here at 35. Now remember, it's actually in thousands. So if I take 50,000 and I find the difference between the 50,000 and the 35,000, we have 15,000, and that's BTU per hour. So there's an example of what we're looking at in chapter 12. And you guys, we're already a fourth of the way done. All right, here's another one. There's such thing as called a double bar graph. And what happens is you're comparing various things, but you're actually looking at two different ways to do that. Okay, so when you're doing a double bar graph, they have to include what is called a key or a legend. Okay, so here, what we're doing is we're looking at the annual earnings of recent college graduates versus people who hold a graduate degree. And you want to see how much more money you make if you have that graduate degree. So again, this is a little bit hard to see with the color. This is the darker of the two options. This is the lighter. This is on the left. This is on the right. Okay, when I photocopied it, the blues weren't as different as they were on my computer. So I apologize for that. This says the following double bar graph shows the median. Now the median is the middle number. The median annual earnings in the year 2011 and 2012 of both recent college graduates. Okay, so we're looking at fresh out of college and then those who have graduate degrees. So they graduated, then they went back and they got a master's degree. Okay, we're looking at 6 different occupational areas. Study the graph and answer the following questions. Okay, so again, before I start, I like to go ahead and just see what we're looking at. We're looking at engineering, nursing, finance, accounting, architecture, marketing, and market research. Kind of cool. These are median earnings. So the number is what it is. Okay, it doesn't say that it's by the thousands. So this is 20,000. This is 40,000. Okay, approximately. So right now we're knowing that we are just guessing the best we can. And that's one thing as you're reading graphs. Sometimes it's almost impossible to get an exact answer. So a lot of times the questions will say estimate or approximate, okay? And that's what we're seeing here. Approximately how much more did the average electrical engineer make compared to the average accountant if they were both recent college graduates? So we're looking on this side and we are comparing engineering and accounting. So this, we'll notice it's a little tiny bit. Notice that this is going by 20,000s, okay? So it's a little bit above the 60. It's set approximate. So I'm going to say I'm guessing about 62. If we're looking at accounting, I'd say that's probably a fourth of the way. So here would be 50. So I'm saying this would be about 45,000. So if I want to know the difference, if I'm comparing the two, I'm approximating that a general engineer, and in this case, they're talking about an electrical engineer, right out of college, they can make 62,000, where in accounting, if you're right out of college, you're probably starting at 45,000. So the difference would be $17,000 per year because these are annual earnings. Okay, awesome. In marketing and market research, so we're looking at this right here. How much more did the average graduate degree holder make compared to the average recent college graduate? So if you're going into marketing and market research, when you first graduate, look at this, it's under 40. So we'll say it's about 38. But once you get your graduate degree, so you go back to school and you get a master's, halfway would be 90. I think it's a little bit less than that. So we're estimating, okay? I'm going to say this is probably about 88. But check this out. So once you have your master's degree in marketing and marketing research, you can make 88,000 a year. But when you first start out, you get 38,000 a year. Again, these are approximate numbers. So by getting that degree, what you're doing for yourself is you are making an additional $50,000 per year. Okay, so these are the kinds of things you want to look at. Once you finish college, go ahead and do some research and say, okay, does it make sense for me to go on and get another degree? Would my salary go up that much? In this case, I would say, heck yeah, get your butt back to school. $50,000 a year more? Absolutely. Okay, next one. For which of the occupations shown did the median earnings increase the most for holders of graduate degrees? So we want to look at all of these and figure out, okay, where did we actually have the biggest jump? Here, this one's pretty high. I mean, that's 50,000. This was 62 is what we said. Let's go ahead. This is 100. I'd say this is 115. So if I subtract them, 115,000 minus 62,000, this would be 53. Holy smokes. Okay, so you actually would make more. The spread here is more for engineering. Okay, so if you're going into engineering, you guys, go ahead and get that master's degree. Look at these stats. Okay, nursing. When you're starting for nursing, 50. And let's say this is, we're going by 20s. It's not quite half. So I'm going to say this is 85. So if you go ahead and get a graduate degree, you would make $35,000 more a year. Okay, so still amazing. So 40, I'd say this is about 48. I don't think it's exactly half. And again, all these are approximate. If I go up here, this is 100. It's definitely not to the 110, so I'm going to go 105. So 105,000 minus 48,000, 57. Okay, again, finance. Get your butt back to school. Accounting, 20, 40, 60, 80. I'd say that's a good half, so this would be 90. 90 minus 45, it's approximately 45. Architecture, hey, you got to love it when it's actually at the line. That's 40,000. This is just under 80. And again, they're going by 20s, so I'm guessing that's about 75. 75 minus 40 is 35. Now, sometimes it is kind of a lot of work. Like, we just had to do quite a bit to answer this question. But in the process, we learned a whole lot. No matter what, if you just got a job right out of college, yes, these are great salaries, but by going back and getting your graduate degree, look at how much more money you would make, and this is every year. So every single year, you would make 53,000 more or 35,000 more. Now, what the question says is for which of the occupations did we have the biggest increase? And for us, that was finance. Finance jumped approximately 57,000 a year. Okay, so that is called a double bar graph. Let's go ahead and look at what is called a line graph. A line graph is used to show changes over time. So any time that you are looking at a line graph, the horizontal axis will always be some kind of increment of time. It might be days, months, years. So here you'll notice that this is months because that's an increment of time. Here it's years. You might even have like 1 p.m., 2 p.m. A line graph always is showing you changes over time. The time increment is always on the bottom. The y-axis is always those numerical data that you're looking for. Okay, let's go ahead and read a line graph. So this is monthly tire sales at Treadwell Tire Company. Okay, if you are looking at, maybe you want to purchase Treadwell Tire Company, right? You want to know all you can learn about it, okay? So if you want to find the number of tires that they typically sell in May, this is the number sold. So if I find May, here's May right there, and it is 750. So typically, they sell about 750 tires in May. Cool to know. Great. What was the lowest monthly total? So the lowest value I see is 550 tires. And when did this occur? This occurred in December. And this would be important to know. Let's say that that's your business. If you know you're selling the least amount of tires in December, that's when you probably want to have the least amount of help on, okay? Because you're not bringing in as much money. Where if you're looking in here like July, August, September, when you're selling so many tires, you better hire maybe some part-time help just to be there to make sure that you can keep your customers happy. So these kind of things are really important to know if you are the manager or the owner of the store. How many tires were sold during the first 3 months of the year combined? So we're looking at January, February, March. Notice we're going by 50s. This is in between 550 and 600. So that'd be 575. Okay, if I look here, February was at 650, and March we were at 700. So if I'm adding, if we're looking combined, we add them all together. So 575 plus 650 plus 700, it's approximately 1,925 tires. That's approximately how many tires were sold during the first 3 months of the year combined. January, February, March, you add them together. Okay, now just like you can have a double bar graph, you can also have a double line graph. All that means is that you're comparing two different things over time. So what we're doing is looking at the U.S. production of oats and barley, and this is in the years 2003 all the way to 2014. Barley is in the black line. Oats was in the blue. And so just looking at this, remember at the beginning they said when you look at a graph, you have to realize it's a story. Okay, you can quickly look and see what's going on. So here are just some observations that you can make from the double bar graph at the right. The production of barley is always greater than the production of oats. This black line always stayed above the oats. So we know that during this time, 2003 and 2014, the production of barley was always greater than the production of oats. Okay. The amounts on the vertical axis are in thousands. So again, that's one thing you always want to look at is your labels. This is production in thousands of bushels. Because it says thousands, you always have to add 3 zeros to whatever number you're reading from the graph. Okay, another thing that we can figure out just from looking at the graph. The lowest production of oats is right here, and it was in the year 2011. And it was approximately 55, and on here it'd be 55,000, but because it's in thousands, you have to make sure that you add the extra 3, so it'd be 55 million bushels. So just an example of how you can read and understand what's going on in a double line graph. All right, last type of graph, you guys. The last type of graph is called a circle graph. And a circle graph, it kind of looks like a pizza, okay? So if you look at this, picture it as a pizza. Here's a piece of pizza, here's a piece of pizza. Every single section, it represents a part of a whole. And notice that they're giving you percentages. When you add the percentages up on a circle graph, you always have to get 100%, okay? So let's go ahead and look at school expenditures. So how much money you were spending on school. You had lab fees, material fees, books and lab manuals, tools, tuition, okay? And they gave you the percentage. Which category represents the largest expenditure or cost? So what you're doing is looking for the largest percentage. In this case, it's tuition. Your tuition was the largest expenditure for college, for school. Which category represents the smallest? So you look for the smallest percentage. In this case, it was the lab fee. It was only 8%. Now here's where you got to think a little bit. If a student spent a total of $2,500, how much of this went towards tools? Tools is 26%, and lab fees combined. Okay, so right now, tools is 26%, plus lab fees, those are 8%. If I add those together, 26 plus 8, well, that's 34%. You want to know what 34% of $2,500 is. Remember, of means multiply. Anytime in math, when you are dealing with a percentage, you always turn it into a decimal. So this is 0.34, because 34% is 0.34 of times 2,500. So if I go ahead and calculate that, 0.34, there's your 34%, times 2,500, it was $850 out of that 2,500 that went towards tools and lab fees. So that concludes, this is 12.1, how do you read graphs? We looked at bar graphs, double bar graphs, line graphs, double line graphs, and circle graphs. Now let's go into our final section of technical math, 12.2. A measure of central tendency is a single number that summarizes an entire set of data. So it's really cool. Like you're given a big cluster of data and they'll ask you for like the mean or the median or the mode. And so your answer is just one value that's going to represent that entire group. So cool. The phrase central tendency, it implies that these measures represent a central or a middle value in the set. So we're not looking at outliers or the biggest value or the lowest value. What the values are, it's kind of the cluster. It's whatever's in the center. In this section, which is 12.2 in your textbook, we are studying what's called the mean, the median, and the mode. And hopefully you have heard those words before. If not, I definitely gave you definitions so you can remember what they are. The arithmetic mean, also simply called the mean, or oftentimes they just call it the average. It can be found using the following formula. You add, remember sum means add. add up all the data values. Whatever the sum is, that is the numerator, the top of the fraction. Then you count up how many numbers did you add. That goes on the bottom. Okay, so the mean, sometimes it's called the arithmetic mean, sometimes just the mean, sometimes the average. Add all the numbers together, divide by how many you have. Another commonly used measure of central tendency is the median. Now, the median is the middle value. If you are trying to find the median, you have to first put all of the numbers in order from least to greatest. Then you cross off one off the front, one off the back, one off the front, one off the back until you find the exact middle number. Okay. The final and perhaps the least used measure of central tendency is called the mode. Now, the mode is the value of the data that occurs the most often. And it is possible that you might have no mode. If every value occurs only once, well, then you don't have a value that occurs more often than the others. So there would be no mode. It is also possible to have several modes. If you go ahead and look at your data set, if you have more than one value, let's say you have two numbers that occur 4 times and everything else just occurs once, then you would have 2 modes because those 2 values occur more often than the others. Okay. And for fun, let's add another statistical term. It is called the range. Now, the range shows the spread of the data. So you want to know what is the difference between the largest value and the smallest value. So what you're doing is you simply take the largest value, you minus the smallest value. That is called the range. So here is a basic example, okay? If you are trying to find the measures of central tendency, step 1, you always have to put the numbers in numerical order. So 21 would come first. 22 would come second. 1, 2, 3, 23. So 23, 23, 23. Boom, boom, boom. Then I have a 24. Then I have a 25 and a 26. Okay, so step 1, all of the numbers go in order. To find the mean, I add them. 21 plus 22 plus 23, 23, 23, because there's 3 of them, plus 24 plus 25 plus 26. Now it's 187. That is your numerator. You add them all together. That's the top. The bottom, you count up how many numbers you have. 1, 2, 3, 4, 5, 6, 7, 8. That's the denominator. So I take 187 and I divide it by 8 and I get a mean 23.375. That is your arithmetic mean, also known as your average. Your median, once the numbers are in order, 1 off the front, 1 off the back, 1 off the front, 1 off the back, 1 off the front, 1 off the back. Now here's the deal. We ended up with 2 numbers in the middle. So our mean is our median, is whatever's actually in between these two. So if I add these two together and divide by 2, 23 plus 23 is 46. 46 divided by 2 is still 23. The value that's in between 23 and 23 would be another 23. Your mode, the number that occurs more often than the rest, is 23. 23 occurred 3 times. Everything else only occurred once. Your range, the largest value minus the smallest value. 26 minus 21 is 5. You guys, that's the last skill of technical math. No, we're not done. I can see some of you are like, hey, are we done? No, we got another page. You got to do some story problems, okay? Last time, a mechanic has logged the following numbers of hours in maintaining and repairing a certain Detroit Series 6 diesel engine for 10 different servicing times, okay? So what's happening is every single time that this mechanic happens to work on that diesel engine, he's writing down the hours that he spent at that particular time. Check that out, 22 and a half hours. He had to have had a lot of Red Bull or something because he must have not slept. Holy smokes. All right, they want us to find the mean, the median, the mode, and the range. Step 1, as soon as you know that you have to find the median, you are going to end up having to write the numbers in order, so I always do that first. The least amount of time that he worked on that engine at one time is 6.5. Then the next smallest number would be 7.4 hours. Then we've got an 8.5. Hopefully you're doing this with me. This will be way more fun doing, not watching. Then we got 9.8. All right, we got 11.2. Looking for the next smallest number, 15.9. These are some long hours. Holy smokes. Then we got 18.0, 19.1, 20 hours, and 22.5. Okay, so step one, I put all of the numbers in order. Now, if I am finding the mean, you add them all together. 6.5 plus 7.4 plus 8.5 plus 9.8, sounds like a rap song, plus 11.2 plus 15.9 plus 18.0 plus 19.1 and 20.0 and 22.5. My numerator, when I added all those numbers together, 138.9 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. So if I take 138.9 and I divide it by 10, the average amount of time that this mechanic worked on that engine was 13.89 hours. Okay, so that was the average amount over the 10 times that he was working on servicing that engine. The median, you got to go ahead and find the middle number. So one off the front, one off the back, one off the front, one off the back, one off the front, one off the back, one off the front, one off the back. I have two numbers in the middle. If you have two numbers in the middle, neither of them is your median. Your median is whatever's exactly in between those two. So the way you find it is you add those, you find the mean. So 11.2 plus 15.9 is 27.1 divided by 2, exactly in the middle of 11.2 and 15.9 is 13.55. So again, when you're finding the median, if there's two numbers in the middle, you add them together and divide by 2. Okay, the mode. The mode is the number that occurs the most often. Every single number here is unique, so there are no modes. Okay, the range, the largest value minus the smallest value, 22.5 hours minus 6.5 hours. The range here is 16 hours. Mean, median, mode, range. Last question. Okay, let's say that you are interested in maybe studying the weather. Okay, one little fun tidbit. If you are somebody who ever takes a calculus class and you love it, meteorology is so much calculus. Okay, so this has always kind of fascinated me. The National Weather Service provides data on the number of tornadoes in each state that occur throughout the year. Use the following statistics to answer questions A through E. Round to the nearest whole number when it's necessary. So we're looking at the number of tornadoes, comparing Kansas and Oklahoma from 2005 to 2015. Notice where I see mean, I see median, so I know right off the bat, I'm gonna have to put these numbers in order, okay? So if I'm looking just at Kansas, the least amount of tornadoes, holy smokes, in a year was 41. I'm like, a month, that would be wild. Okay, and then 55, but that's insane, that's a lot of tornadoes. 68, again, make sure you're doing this with me. I know this is like, yeah, I understand how to put numbers in order, right? I get that. But the more you practice, the more comfortable you'll be. And these are skills that are going to be on your final test. And I know you want to rock it so you can go out with a really good grade and be proud of yourself. I'm just putting the numbers in order. Make it fun. Okay, and 187. So I'm going to go ahead and I'm just going to do everything that has to do with Kansas. Here's Kansas, here's Kansas. Okay, now find the mean. Holy smokes. Okay, I always, like when I was in high school learning about this stuff, I always could remember the mean because I felt like it was the meanest. It was the most work. You have to add all those numbers together and divide. So the mean is the mean one. It's the most work. It takes some time. But we've got it because you're rock stars and you made it through an entire textbook this semester. And I'm super proud of you and I hope you know that. And I do miss seeing you in class. This darn online stuff, not so fun, but we made it. Okay, so 1,131 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Go ahead and divide by 11. Oh my gosh. Okay, so the mean is 102.8. It says to round it to the nearest whole number. So the average amount of tornadoes in Kansas per year for that 11-year period is 103 tornadoes. That is wild. I am never moving to Kansas. Okay, find the median number. 1, 2 off the front, 1, 2 off the back, 1 off the front, 1 off the back, 1 off the front, 1 off the back, 1 off the front, 1 off the back. Hey, we actually had a real middle number here. The median for Kansas, the middle number is 95 tornadoes. Now for part E, it says the largest range. So let's go ahead and find the range. The range is the largest number minus the smallest number. So for Kansas, it's 187 minus 41. It is 146. Okay, now let's look at Oklahoma. Fun fact, when I was younger, I used to do a lot of musicals, and I actually was in the musical Oklahoma. Kind of fun. Okay, Oklahoma, the least amount of tornadoes in a year, 16. Let's look at the next smallest number. Hey, this doesn't look so bad. We got 27. Granted, I would not want to have 27 tornadoes or 28 tornadoes in a year. 33. Keep on looking. Now, this is real data, you guys. So, I didn't just make these numbers up. These are real charts. Maybe you don't want to go to Oklahoma or Kansas after studying this. 77, 82, 102, and 111, and 119. Okay, so I put all the numbers in order. B says to find the mean. The mean, remember, that's the mean one. You got to add it all together. So if I go ahead, 16, just make sure you have that darn calculator handy. Can you imagine how much your head would hurt if you tried to do this by hand? And I would never do that to you, just so you know. Sorry, I'm kind of a chatterbox today. There we go. Okay, so I added them together. Hey, 708 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I take 708 and I divide it by 11, I get 64.36. Now it says to round it to the nearest whole number. We studied rounding in this class. Remember the 3? That's not big enough to bump it to a 65. So the mean is 64 tornadoes. Now the median, I gotta find the middle number. 1, 2 off the front, 1, 2 off the back, 1 off the front, 1 off the back, 1 off the front, 1 off the back, 1 off the front, 1 off the back. There is the middle number. So the median, the middle amount of tornadoes in Oklahoma between the years 2005 and 2015 was 63 tornadoes. Now the range, because the last question, they want us to go ahead and compare the ranges. So if I'm finding the range, you got to go 119 minus 16. The range is 103. The question said, did Kansas or Oklahoma have the largest range? Well, 146 is bigger than 103. The range 146 came from Kansas. And you guys, you just finished technical math. There is no assignment for chapter 12. However, you will see a bunch of these skills on exam number 4. I will get that uploaded, and the exam is due by midnight on Thursday. I believe in you. You can finish this class strong. Thanks for sticking it out with me, hybrid and then online. I appreciate all your hard work this semester, and I really enjoyed being your teacher. I will talk to you guys soon. Take care.